All right, I want you to do something for me. Just look down at your hands. Seriously, every atom that makes up your skin, your bones, the blood flowing through you right now, it wasn't born here on Earth. Except for the hydrogen, every single piece of you is literal stardust, forged in the heart of a star that lived and died billions of years ago.
You know, this isn't just some nice, poetic idea. It's a scientific fact, and that's the heart of what we're going to get into in this explainer. We're going to trace your personal atomic family tree all the way back to its cosmic beginnings.
I mean, it's a wild question when you really think about it, right? How in the world do you get from this massive, violent explosion out in the middle of space to the complex, living, breathing person sitting here right now? Well, that's the journey we're about to take.
So first, let's look at the recipe that makes, well, you. By mass, you're mostly oxygen and carbon. Now that 10% hydrogen, that's special. It's an actual relic from the dawn of time itself. But the other 90%? Yeah, that stuff has a way more dramatic and fiery origin story. These are the main characters we'll be following.
To really get where these ingredients came from, we've got to rewind the clock. I mean, all the way back to the very beginning, to a time when the universe was incredibly simple and, honestly, kind of boring.
So in the very first few minutes after the Big Bang, the whole universe was basically one giant nuclear furnace. But it cooled down so fast that it only had time to cook up the two lightest, simplest elements, hydrogen and helium, plus maybe a tiny little dash of lithium. And for the next 400 million years, that was it. That was the entire periodic table.
And here's the thing. The early universe had a major problem. You just can't build rocky planets, you can't make water, and you definitely can't create life with just hydrogen and helium. The cosmos needed to get creative, so what did it do? It built factories.
And those factories were the very first stars. They are the cosmic engines of creation, the places where the universe started building all the rich, complex chemistry that was needed for, well, everything that came later.
The process they use is called stellar nucleosynthesis. I know, it's a mouthful, but it's a really powerful idea. In the incredible heat and pressure inside a star's core, lighter atoms get smashed together so hard they fuse and create heavier atoms. It's basically cosmic alchemy, turning simple gas into the stuff of world.
Now, not all these stellar factories are the same. Stars about the size of our Sun are fantastic at taking helium and fusing it into carbon and oxygen, which are the absolute backbone of life. But to get the rest of the ingredients, you need something way more dramatic. You need a star at least 8 times bigger than our Sun.
And this is where the story gets really epic. We're leaving behind that gentle simmering of sun-like stars and diving into the high-pressure, high-stakes fusion happening deep inside a true stellar behemoth. You can think of the inside of one of these massive stars as a kind of cosmic onion. With each layer deeper and hotter, the star is fusing heavier and heavier elements, fighting this constant war against its own gravity. It goes from hydrogen to helium, then carbon, oxygen, all the way down until it makes iron. And for a star, iron is the end of the line. It's like nuclear ash. See, with all the other elements, fusing them releases energy, but fusing iron actually sucks energy out of the core. The star's engine just shuts off. Instantly, in less than a second, gravity wins, and the core collapses catastrophically. But here's the amazing part. This moment of death for the star is the ultimate moment of creation for the rest of us. That core collapse triggers this unbelievable rebound, a shockwave that just rips the star apart in one of the most violent events imaginable, a supernova. So get this, the very element that killed the star triggers the event that seeds the galaxy with everything needed for life. In that one brief, furious moment of a supernova, all the elements heavier than iron are created and blasted out into space. Just think about this for a second. The calcium in your bones, the potassium that helps your nerves fire, the iron that carries oxygen in your blood, all of it was made and delivered by one of these spectacular explosions.
Okay, so a star goes boom, scattering these precious elements all over the galaxy. But how did that cosmic inheritance get from a cloud of gas and dust into you?
Let's make the connections really clear. The carbon that forms the backbone of your DNA, that came from a star like our Sun. The oxygen you're breathing right this second, that came from both types of stars. But the iron that allows your blood to carry that oxygen, that could only be forged in a supernova. There's no other way. Every atom has a story.
So for billions of years, generations of stars lived and died, enriching the galaxy with heavier elements. Then, about 4.6 billion years ago, our little corner of the galaxy got its turn. One of these enriched clouds of gas and dust collapsed under its own gravity, and that collapse formed our Sun, our Earth, and everything on it, all built from the recycled ashes of dead stars.
So what's the bottom line here? What does this all add up to? Well, if you take out that ancient hydrogen that's been around since the Big Bang, a mind-blowing 93% of your body's mass was cooked up inside the core of a star. You are overwhelmingly, profoundly, a creature of the cosmos. And that really leads to this final incredible thought. You see, we're not just living in the universe. We are a way for the universe to know itself. The iron from a star's violent death now lets a brain think about that star. The carbon fused in a stellar core now lets a hand write about it. We are stardust that has evolved to the point where we can look up at the night sky and finally understand where we came from.